Hi, this is Ratan Gupta from Knowledge Varsity, and we are solving a problem related to the probability, and this is very much useful in your FRM part 1 examination. Okay, this is a very standard problem and it is being asked in the past examination, and it's a highly probable question. The question says that the probability that a firm will default in a year is 0.3, and they are saying that assuming that this probability of 0.3 of the probability of default, it remains the same for subsequent years. Okay, they are asking you to compute the probability that the firm would be in default at the end of the years. Please note that here they have not mentioned that it is cumulative probability of default, but since they have mentioned that the firm would be in default at the end of the year, so you have to find out cumulative probability of default for all the years. That is, the firm can be in default at the end of 1 year, it can be in default at the end of second year, and so on. So this is what you need to find out, right? So let's see how to compute this. So this first, let's understand this how to solve, and then it can be computed very easily. So let's try to create a tree diagram wherein we are saying that we are at this point at t equal to 0, and the condition is that at the end of the first year, so this is t equal to 0, at the end of the first year the firm can be in default state or not default, and we know that the probability of default is 0.3, so this probability is 0.3, and the probability of not default is 0.7. Okay, now again 1 year passes, let's say this is t equal to 2, and the company in this second year can be in default or not default. So again you know that default is 0.3 and not default is 0.7, right? So again the third year the firm faces the same situation, either it can default or not default. So the third year you see the same situation, and the same situation you see in the fourth year, so default or not default, right? So this is what the condition is. If I draw the tree diagram much more better, it will look like this. So let's see the tree diagram, much more neat tree diagram. Default, not default, default, not default, default, not default, default, not default. So this is the situation at the end of fourth year, right? We know that this not default probability is 0.7, 0.7, 0.7, 0.7, and this is 0.3, this is 0.3, 0.3, 0.3. Now let's term this node as 1, this as 2, 3, 4, and this node as 5, right? So what I can say is the firm, if I want to find out the probability of default, that means I have to compute that the probability of node 1 plus probability of node 2 plus 3 plus 4. Okay, now you will find that this is a very cumbersome approach. So you have to find out the probability of node 1, which is 0.3, plus what is the probability of node 2? If you see this probability of node 2, we can say that the probability of node 2 is the joint probability of this node and this node, which is 0.7 and 0.3. So probability of node 2 will be 0.7 into 0.3. What is the probability of this node 3? It will be the joint probability of this node, and this node. So 0.7 into 0.7 into 0.3, and then you need to compute the probability of the fourth node, which will come over here, which is this into this into this into this. So 0.7 to the power 3, because it is coming 3 times, into 0.3. So this complex calculation you have to do if you have to compute the probability of default, right? So you have to find out this and add. This is in examination it will take a lot of time. What we can otherwise do is think about this node 5. The firm is not in default. So in this node 5 the firm is not in default, so that means the company is alive at node 5. So can I say that probability of default, so probability of default plus probability of not default is 1, because these are mutually exclusive and collectively exhaustive event. Now what is the probability that a company is not in default? So that means we need to find out the probability of this node 5. How do you find out? The probability of node 5, so probability of not in default, can I say that probability of not in default is the probability of node 5. So probability of node 5, the node 5 probability is simple, it is 0.7 into 0.7 into 0.7 into 0.7. So that is, the probability of node will be given as this probability, node this, this, this and this. So it is 0.7 to the power 4. So I can write that probability of default, so probability of default plus probability of not default, which I know probability of not default as 0.7 to the power 4, right, equal to 1. So I can say that the probability of default is 1 minus 0.7 to the power 4. Another way to write the same is equal to 1 minus this 0.7, we have said that it is equal to 1 minus 0.3. So this can be said as 1 minus 0.3, or probability of default in 1 year, correct, to the power 4. So 1 minus probability of default. So if you see this way, I can write it is 1 minus 0.3 to the power 4. Now the computation of this is much simpler over here. So what you will do is you will compute this as 0.7 to the power 4, so y to the power x 4, okay, and then I will subtract from this from 1, so I can this plus minus, I can put this as minus and add 1 over there, so it is 0.7599. so the probability of default is 0.7599. so this is a easier method. Now in the lengthier method you will see we can get the same answer. What we have to do is find out this probability. So if you see that we are computing actually 0.3 plus 0.21, and then you are computing 0.21 into 0.7, so which is 0.147 plus this into 0.7, so 0.1029, okay, and you add all this, it will get you the same answer. So 0.3 plus 0.21, 0.51, 0.14, 0.657 and 0.7599. this is this and this is the same, so you will get this. So anybody ask you what is the probability of default, okay, in n year, it will be given as 1 minus probability of default in 1 year to the power n. This would be the formula. Okay, so thanks for watching the video. I hope it would have cleared your concept. This is Ratan Gupta from Knowledge Varsity.